All right, so after multiplying, we are going to factor. And factoring is the opposite of multiplying everything out. So if factoring is the opposite of multiplying, then we're talking about division. So greatest common factor is the biggest number that we can divide out. And we have to use brackets. So what I do is I look at 6x squared, that's the first term, and the second term is negative 24x. And I have to think in my head, what is the biggest number that divides into both of those? That's what makes it common. So if you want to start with the numbers first, you can have a multiplications table nearby, but I recognize that 24 is actually a multiple of 6. So that means 6 is a multiple of 6 because 1 times 6, and 24 is a multiple of 6 because 6 times 4 is 24. And then I'm going to look at the letters. And this one is x squared, and this one's x. So I have to think, what's the biggest one that can divide into that? Well, there's definitely an x in both of them, but can I go to x squared? No, because this is an x squared. It's always the biggest one that's in both of them. The biggest one is just 1x. So now when I do this, and I'll do this the long way the first time, I'm going to put 6x squared, that's the first term. But what I want to do is out here, when I put something out in front of the brackets before, I multiplied it. What's the opposite of multiplying? Dividing. So essentially, if I multiplied this out, I'd get back the 6x squared, because 6x divided by 6x is 1. I'd be left with a 6x squared. But I'm factoring out, so just wait and see what happens here. I'm going to do the same thing here. Negative 24x. I'm going to divide by 6x. I know this is the long way, but you can do the shorter way when you get used to this. All right, so the 6x out in front, I chose to divide that out. So now I'm going to divide it out of this. 6 divided by 6 is 1, and x squared divided by x, that's only 1. I'm going to give a little breakdown of this. X squared is like x times x. And if I divide by x, well, I was said before in the other one that if you divide by something that's the same, it's 1. So I'm just left with an x. So I'll do the same thing here. I put the negative, because that is the minus sign in between there. 24 divided by 6 is 4, and x divided by x is 1, so I don't have any x's left over. So I've factored out the 6x. Now on the sheet before, we were multiplying out. This is the answer, 6x, x minus 4. If you want to leave the 1, that's up to you, but I don't. So, is this the same as what's up there? This is the factored form. Factored means I've divided the biggest thing out. So if I want to check if I got the right answer, I have to distribute and multiply out. What's 6 times 1 is 6, and x times x is x squared. 6 times negative 4, check that on your calculator, it's negative 24, and x times 1, because there's no x there, is x. So look back up here, and that's the exact same. This is a check. You don't need to do this, but I'm just showing you what factoring is. If I multiply and divide by the same number, I haven't changed it. So I show that I've factored out the 6x, but what I've had to do is divide it out of those terms, so that's why I've put it out front. So we look for the biggest number that can be divided into both of them. Now I can purposefully maybe do this one in a couple steps in case maybe you make a mistake. Let's say I think that 24 is the biggest, or sorry, let's say 2 is the biggest number I can divide, or 12. Let's pick 12, because I recognize that 24 is 2 12s and 48 is 4 of them. So let's go ahead and factor out a 12. And I see that there's an x in both of these. So let's go ahead and factor that out and see what happens. So what I do is I factor out, or I divide what I put out in front. So I write down everything that's there and I divide out what I put in front. So write down the 12x. Now, 24 divided by 12 is 2, x divided by x is 1, so I'm just left with the y squared, minus, because this is a positive underneath here, 48 divided by 12, that's 4. X divided by x is 1, so I'm left with a y. And I look at this and I think, wait a second, I didn't even think about looking at the y's. And I noticed that 2 and 4, I know that they're both divisible by 2. So if you make a mistake, it's really not a mistake. It's just you've done it in more steps. So you can factor out again. I'm going to put brackets around this just so that it doesn't get confusing. Factor out a 2, because we know that these are both divisible by 2, and I factor out a y. So now I do that thing where I divide out. Divide out the 2. 2 divided by 2 is 1. Y squared divided by y is y. And you can also think back to grade 9, it's subtraction when we divide with exponents. But I know that that one's tricky. And then we go minus. I have to divide negative 4 by 2. That's negative 2. And I divide by y. I'm just left with that. Now, I should simplify this stuff here. And that ends up being 24, 2 times 12, and I have an x and a y. I don't really need to write the 1. So this would be the fully factored form. If you had factored something like to this, you'd get part marks. But fully factored means to factor out the greatest common factor. And again, if I multiplied this out, 24 times 1 is 24. X, there's not another x, so that's why there's an x, and y times y is y squared. And then this one, you'd multiply this whole thing by negative 2. So the x and y wouldn't change, there they are, but the 24 would become a negative 48 because there's a negative sign here. So you'll have to look and think, what's the biggest one? So I always look at this number and think, hey, 3. That is the biggest number that can divide into that. Is 12 divisible by 3? Yes. Is 24 divisible by 3? And if you're not sure, check it on a calculator, because 24 divided by 3 is 8. So yes, it's divisible. Now, the one thing we haven't talked about is we really don't want to have a negative term on that first, or a negative sign on that first term. So we should factor that out. We should never have a negative sign there. So we're going to factor that out as well. So I have negative 3. Now I'm going to look at my letters. I've got an x squared in this one. I've got a y, no x's. And I've got no x's here. There's no common letters. So all I can factor out is a negative 3. So if I do this the long way, I have to divide every term by negative 3. I'm going to put these in brackets because this one's a little bit more complicated. This one I made complicated with the signs. So negative 3 out in front, that's staying there. So negative 3 divided by negative 3 is 1. So I'm just left with the x squared of that first term. Now here I have a negative 12 divided by negative 3. So 2 negatives. That's going to end up being positive. And 12 divided by 3 is 4. I leave the y. And this one is a positive divided by a negative. So that's going to end up being negative. And that's going to become negative 8. And that would be the fully factored form. All right. So now we're going to factor trinomials. We're not looking at a greatest common factor. This is that what multiplies and what adds to. So we take this number, we put it up here on the top of the diamond. We take this middle number with the x and put it down here. And we say to ourselves, what multiplies to 100 that adds, okay, to 20? Negative 20, sorry. I'll make that a little bit bigger so we can see it. I'm going to do it down here. So what multiplies to 100 that adds to negative 20? So go through multiples of 100. Now they have to add to 20, negative 20. And I think, whoa, well 10 times 10 is 100. So that works. But I need them to add up to negative 20. So that means I need it to be a negative number. So those must both be negative. Those end up being my factors. The one other trick I taught you is if this is a positive, that means they're both the same sign of that one in front. So now with the factors, because this is x squared, we have 2 big brackets. There's 2 of the x's. The signs are both negative, and the numbers that multiply to 10 that add to negative 20 are 10 and 10. Now, if we remember back to this one, I'll flip back to it for a second. These two are exactly the same. I could make it with a squared. Well, I'm going to do the same thing here. Because these two terms, these whole brackets are the same, there's two of them. So that can be x minus 10 all squared. That happens to be a perfect, as I do, square. Okay? So we're going to do this one here. So what multiplies to negative 20 that adds to negative 8? So this negative sign, that means they're going to be opposite. There's one that's going to be a negative and one that's going to be a positive. Now how do I know which one's which? They're going to add up to be a negative value. So that means the bigger number is going to be negative. So what are multiples of 20 that add to 8? So let's do this. 1 times 20. That multiplies to 20, but that doesn't add to 8. What about 2 times 10? Ooh, now, if I think about them adding, they add up to 12, but their signs are different. So I need to think about what the difference is between those two numbers, and the difference is 8. So that multiplies to 20, but if I did 10 minus 2, that's 8. But I want that to be negative 8. So I know that the multiples are 10 and 2, but I want them to add up to be a negative number, so the bigger number has to be negative. So negative 10 plus 2, and those are my factors. Now this one, if you don't recognize this, there's no term here. There's no middle term with an x. That's one indicator that it is a difference of squares. You guys know I can't spell difference of squares. What does that mean? Well, it almost looks like this one, but with opposite signs. So it's x, x, but one is a plus and one is a minus. Now what number goes here is the square root. So the difference is the negative and the perfect square is the 121. So on your calculator, what you can do is check to see what the square root of 121 is, and that's 11. So that number goes here, and they're opposite signs, because what happens when you multiply this out, you get x squared, you get plus 11x, you get minus 11x, and then you get minus 121, because that last term is negative 11 times positive 11. But what you notice about these middle terms is they are exactly the same but opposite sign. So they end up adding to be 0, and we're left with x squared minus 121. So that's how we can identify a difference of squares. This would be the answer up here. This is just me showing the reasoning. So how do you identify difference of squares? That's a special one. Difference of squares. So difference of squares, there's a subtraction, and they're both perfect squares. So let's look at this one. 9x squared. Can you square root that? 9 is a perfect squared, so sometimes what I do is I'll write it like this. 3x squared. Is that the same thing? It is. It's a perfect square. What about 25? Well, 25 is 5 squared. So now there's my difference. Difference is meaning like with a negative, and a difference of squares. So, oops, can I fit that one here? So it's going to be 3x minus 5. This is going to look almost exactly the same, but 3x plus 5. They look the same, but the signs in between are different. All right, I can fully factor by identifying a greatest common factor and then factor again. So this is combining what we've done up in these two sections here. So first, I'm going to look at this and say, hey, there's a's in all of them, and 8 is an even number, and 42 is an even number. They're all divisible by 2a. So I factor out a 2. 2 divided by 2 is 1. 8 divided by a is 1, and I'm left with an x squared. This is a positive number, so I don't have to really worry about changing the sign. 8 divided by 2 is 4, and a divided by a is 1, so we don't have to write it anymore, and we write x. Then I have a minus sign, negative. 42 divided by 2 is 21, and a divided by a is 1, so there's no more a's. I prefer to write it like this. And now I can see this is a trinomial. All right? So I didn't go over what a trinomial is here, but this is the x squared, and then we have a positive or minus, but then there's going to be a number times an x plus another number, and they'll decrease x squared x and then no x. And there's the three terms, a trinomial. It's also a specific quadratic, right? So I'm going to go down to my diamond thing. What multiplies to negative 21 that adds to 4? So 21 isn't one with a lot of multiples. 1 times 21. There's no way that there's a difference or they add up to 4. It's not an even number, so 2 is not a divisor. So what about 3? Oh yeah, 3 times 7, that equals 21. If I add them, they're 10. But am I worried about adding them? No, because one of these is a negative, because I have a negative number up here. So I want them to add up to be a positive number, but it's smaller than both of them. It must be negative 3 and plus 7, because when I add those, I get positive 4. All right, so what you can do is do 3 minus 7, that's negative 4. 7 minus 3, that's positive 4. And it's not adding, because 7 plus 3 would give you 10. So if you want to go through all that reasoning, you could. And then you know that's the answer, a positive 7 and a negative 3. So leave the 2a out in front. We've already dealt with that. But now this is factoring a trinomial. So we have an x and an x. We know that they're opposite signs. And the bigger number is going to be positive, and the smaller number is going to be negative, because they need to add up to be a positive value. So this right here is our thinking. All right? And this is the final answer. So I common factored, and then I trinomial factored. That's what I'll call it. So here we go. If you're not sure, get out a calculator. Always check if that first number, you can always divide a number by itself. So 3 divisible by 3, yes. 18 divisible by 3, yeah, that's 6. So this is an x squared. If I divide out a 3, I divide a 3 out of 18, that's a 6, negative 6x, because the sign, I haven't done anything with the signs. I haven't been dividing by any x's, so that doesn't change. And negative 48 divided by 3, that is 16. So now there's my trinomial, an x squared, an x, no x. So here we go, my diamond. What multiplies to negative 16 that adds to negative 6? And remember, we have to worry about signs because they're going to be different. This is negative, so they're going to be different, but when they add up, it's going to be a negative number, so the bigger number is negative. So 16, always do one first, but they're not going to add up, because if they add or divisible, or sorry, add or subtract, they're too big a number. It's not going to get negative 6. It's 17 or 15. So what about 2? 2 times 8, that equals 16. Hey, what's 2 minus 8? That's negative 6. What's 8 minus 2? That's positive 6. So it's not that one, it's that one. So 2 minus 8. Leave the 3 out front, give yourself some big brackets, put your x's, one's a minus, one's a plus, 2 and a negative 8. Put the negative, put the 8 with the negative because it's the bigger one. And there we go. There's our factor. All right, now I'm looking at this and I'm thinking difference of squares. But if I checked 18, the square of 18 is not a perfect square. It comes out to be some decimals. But 18 and 50, those are both even values. So I'm just going to try and factor out a 2 first. 18 divided by 2 is 9. Haven't done anything with the letter, so the x squared stays. And 50 divided by 2 is 25. I always think of money. 50 cents or $50. If I had to divide it by 2, I'd get 2 sets of 25. So now that I look at this, this is a difference of squares because 9 x squared is a perfect square, and 25 is a perfect square. How do I get 9? I get 3 times 3. How do I get x squared? Get x times x. Then 25 is 5 times 5. So that's just the first one. The second one is going to look exactly the same, but with a different sign. So I think about that like this. I think square root. 9 square root is 3, and I always think of x times x. That's where I get that from, and you have to think back, will that square and get back to it? Yes. So that's how I know it is a square. 25 square root is 5. Don't worry about the negative. Don't put that under the square root, because you'll get an error on your calculator. It's an imaginary number. This, when I say difference of squares, that difference just indicates with your plus and minus there. All right, we're over the 20 minutes, so this is going to go into 2 sections on the 2 videos. So now I want to find the surface area of a student's desk, represented by this. It asks what are the dimensions of the desk. So if the area of the desk is represented by that, what it means is there's a length and there's a width. Well, I need to factor that, because what I want is I want 2 brackets that add up to that, or that multiply out to be that. So I need to factor that. So I have x squared minus 5x minus 50. I wrote that down right. All right. So what multiplies to negative 50 that adds to negative 5? Well, right away when I see 50 and 5, I don't know why my brain goes right to 10, because I'm thinking 5 and 10, and the difference has to be 5. So 5 times 10 does equal 50, but I want one of these to be a negative, because I have to have it come out to be negative. So does 5 times negative 10 equal negative 50? Yes. What if I add those 2 numbers? 5 plus negative 10. Yep, that's negative 5, because 10 is double 5, and I'm going to be left with a 5 there. So it's negative 10 and a positive 5. So when I factor this, this is x minus 10 and x plus 5. So if we think back, area is equal to length times width. So the length could be equal to x minus 10, and the width could be equal to x plus 5. Now, would it be the same if I put width here and length? Yeah, it doesn't really matter, but there's the dimensions of my rectangle. X minus 10, x plus 5. But now they're saying, what are the actual dimensions if x equaled 100 centimeters? So right there, that's a substitution. So length equals x minus 10, but x is equal to 100, and I want to subtract 10. So 100 minus 10 is 90, but don't forget, there are units on that. So the length of my rectangle is 90 centimeters. The actual dimension, and the width is x plus 5. So that's going to be 100 plus 5, because x is equal to 100, and that's 105 centimeters.